Can you see my the screen? Okay. So my name is Minjae Lee. The Integrated Circuits and System Laboratory is the lab that I have. So this is the next slide. So are you seeing the next slide? This is course information. The textbook is Westy and Harris.
Yes, I can see.
You can see? No problem.
Yes.
So the textbook is written by Westy and Harris, and prerequisite is electric circuit theory and digital design, electronic circuits. So you have to be aware of these all the contents from the prerequisites. Okay, so course organization is as follows. Midterm is 30%, final is 40%, and homework and project is 30%. So over the last several years, we had not enough time for homework and project, but during this semester, we will do more on the homework and project. Do you guys have any one of you have problem with the Linux system? No? So we are gonna do the simulation, actual simulation and coding stuff from the homework and project. So you need to have an account for tool use. So right now we have quite lots of students. So we will have some lab sessions for you to learn about how to proceed the simulation, etc. Okay. So back in old days, 1946, ENIAC is the first computer that we have known. This occupies a whole room like this, very large area, the computer system was used. But nowadays we have on the right a CPU. Looks like this is quite old technology, but you can see a little more detail inside if you look carefully. So there's just some vertical line, like green lines like this, and also sometimes the pink line, and also you see the horizontal lines like the bluish lines. Can you see my pointers? No, right? Oh, you see? Mouse, okay. So all these are different metal layers. So interestingly, if you look at from the scope, you will see a little different color for different metal layers, because it has a different layer, different depths. I mean, the actual metal layers are implemented in different layers. So, and also there's at the boundary we have some wire bonding, right? You can see the wires, right? All the signals are connected through these metal wires, and then the surrounding is called a package. The package is something that you can put your die in the middle you have a square that is called the die, silicon die. And such a die is connected through the wire bonding with the package. The packaged chip, this is the packaged chip. You can put that into your board, and then you can build the system. For example, this is the computer board. You see, here you can put the CPU there, and then we have the North Bridge chipset that deal with the data transfer between memory and the CPU, and also we have a South Bridge chipset that handle the data transfer between the I/O, like disk drive or something, all these kind of different device, external device. You have a SATA connectors here, and there's some SATA. Probably this is what controllers. So you can see many components in this motherboard, right, inside the chip, inside this board. So our role is to build our job as a circuit designer. We are designing the circuit, integrated circuit, to have some functioning chip. So we have a chip that function as a part of a whole system. So this is also quite bulky and very large. Nowadays, the people, this is iPhone 12 boards. You carry all the phones around you, and if you tear down your mobile phone, then you can see some similar structure. Like at the core, you have a CPU that is called here Apple A14 Bionic SoC. So SoC means the what, system on a chip, right? So you have a CPU, and then also on the right you have an ultra wideband chip that communicates with other device. This is a wireless communication chip that transfer the data to your the TV or some Bluetooth, some kind of thing. And also you need a big chipset that actually transfer the mobile data and voice or whatever. So this is the 5G LTE transceivers. And this is a RF analog chipset. On the right hand side we have this digital chipset that process all the communication signal, right? This is the 5G modem. And also we have a duplex on the left, that is RF high frequency components that transmitter and transmit band and receive band filtering is there. And also on the right hand side we have also the power management IC and also memory element like a flash here. As you can see here, you have a very small computer system within on your you can place your computer on your hand, right? This is so small. So now you can think of what would be the driving force to make system such small. As you can see, the compared to motherboard, you have a big, very many chipsets around here. We can integrate all the function into a single chipset. Then you can bring our system into a very small form factor, like a very small. We can make it very small. So as the technology the advances, we are trying to put all the function into a single chipset. In that way, we can make every system small and efficient, right? So nowadays, the semiconductors are everywhere, right? So recently, we are at the wireless. We have at the 5G era. So the speed got up, and then we have to deal with a very large big data throughout the internet, and the network is very the complicated because we have to handle so many data, right? And also we have an internet of things around you, so all the small gadget, all the electronic devices collect all the information from the sensor, right, and then process and then deliver that data to the cloud through the network, and all kinds of thing happens. So all these data, for example, in the electric car nowadays, they have all the sensor like a camera around inside the car, and then such large image data is transferred to the central unit like ECU, and it processes the videos. Even there is a lot of traffic will going through this inside the car, right? And then also, even between the cars, we have to deliver many data, right? So all these comes down to the data traffic. We have to transmit, receive the data efficiently, and also we have to process efficiently. So all these things are done by what? The semiconductors, right? So for the semiconductors, someone may design the device like this. Someone may design the circuit based on all the devices, right? If you can think of a house building, when you design a house, what you need is you need the bricks and sand and all these material for building a house, right? The designer actually bring those material into a nice looking house, right? So circuit designer collect all the devices and put things into together and making it function as we need. Okay. So if you look at the top 10 sales leaders worldwide, first rank is so this is for the Fabless company list. Fabless means they don't have a fabrication factory. They just design the design a circuit and deliver that circuit to a company that fabricate actually and make the chipset. So the Qualcomm is Fabless company. That is number one rank. They have the largest sales revenue. The second one is Broadcom, and the third one is the Nvidia. You know that Nvidia is dealing with graphic processors, right? And so MediaTek and AMD and Xilinx and Marvell, Novatech, Realtek, and Dialog. Up to 10 top sales leader. Can you see any Korean company over here? Actually, there's none of them the Korean company. So you know that the Samsung is number one in semiconductor business, but they are doing best in the memory business, not they have their own fabricating factory, right? But all these companies doesn't have their own factory. They just have a manpower to design all different kinds of the circuits. So if you look at the Korean Fabless company list, we have a Silicon Works at the top, and second one is AD Technology, and then etc. The Silicon Works nowadays, its name has changed to LX Semiconductor, that is owned by LG Electronics. So this is like a LG Electronics. They trying to make things working in the semiconductor, especially design company so area. So they have a very large revenue in Korea. Mostly they provide the display driver IC for the TV and the Apple display is mostly provided by the LG display. So Silicon Works actually provide a chipset for display like a OLED display or LCD display. As you can imagine, if you want to have a challenging or the top-notch design without supporting without having semiconductor chips, you can have a good competitive product. You cannot have a competitive product. So the circuit designer's role is very becoming critical that actually give an edge to the electronic companies like Samsung and Apple. For example, let's say you made a TV system. You made the display, then you don't have a driving semiconductor IC. So you may go out and try to find any supplier who can do the display driver IC. Let's say Samsung found the company, and LG also found the company, and every company go out to find such driving IC company, and then if they are using the same driver ICs, they don't have the differentiation. Most of the circuit, most of the system will have a similar performance, right? So if you want to have a top-notch performance, you have to have your own system and also your own IC suppliers. That's why Samsung, Apple, all these kind of electronic company, they trying to maintain a sole provider, and also trying to find the good company, or they wanna build their IC by themselves, so that they can have a competitive product in the end. So that means all these sums up that we need lots of people, lots of the designers in our in the industry, in this kind of industry. But it would be difficult for the school to provide all these required the manpower. So we need. That's why nowadays the Korean the Samsung trying to invest many things into the system semiconductor other than memory semiconductor. The system semiconductor, like they are trying to support the Fabless company and house, and they are trying to do a business other than the memory. So they trying to have a business in foundry business. So foundry means this is the factory that get all the design from Fabless company. So Fabless company provide the design to foundry, and then foundry make the chip for the Fabless company. So in this business, the Samsung has actively looking for a opportunity, this kind of foundry business. So worldwide, number one foundry company is TSMC, that is the Taiwan company. So Samsung is trying to catch up such foundry business. And also the government also trying to support this kind of the semiconductor K belt, semiconductor belt. So in many places they are related to the semiconductors. Uh, the government invest many money, lots of money to promote semiconductor industry. Okay. So throughout this course, what we will cover is that first we will understand the CMOS fabrication process. Once we understand the how the CMOS device, how the transistor is fabricated, then we will move on to the combinational logic gate design. We will do some performance analysis and optimization in terms of delay and power. And then we will move on to sequential logic design. Those sequential logic dealing with the memory element like a memory itself and also latch or flip-flops. So this kind of sequential logic behaves differently based on the previous data sequences. So this is the something that we have to learn. So for the digital design, if you understand the combination logic and the sequential logic, then that's all. So you have to do some mixture of those two kinds of logic style. For example, combination logic is something that if you put input for certain input, then you always expect the same output. So input and an output relationship is predetermined. But the sequential logic case, it also depends on the history, the data history. So at this moment, if you get the data for the current time, you will not always get the same output because it also look at the previous history. So that history is stored and onto the flip-flop or memory element. So using that memory value and the current input value or the current output is evaluated. Okay, so combination logic output is always depending on the current input, but the sequential logic output depends on current input and the previous history. Okay, and also we will learn about how to construct the arithmetic unit design. For example, like an adder and subtractor and multiplier and divider or all kinds of different logic, but we will mostly focus on the adders and subtractor and a multiplier, right? Okay, and once we learned all these arithmetic unit design, then we will move on to the RTL Verilog design. So hierarchy. So in this register transfer level Verilog design, we write a code for our synthesis. Synthesis means you write some program. The CAD tool automatically translates those code into all the combinational logic gate and sequential logic gate. So this is the recent advances in our the digital design. So if we have a time, we may try to actually do the synthesize all the digital and then place and route your design, but I'm not sure whether we can have such time for this semester. Okay, and when we learn that RTL value design, we have to adopt a hierarchical design and verification methodology, and again the combinational and sequential logic design. Okay, so any question from audience? No? So today is the first day, so I'm not gonna go into detail. So we will wrap up here. Do you have any other questions? No? 자, 그럼 여기서 전자회로나 우리 prerequisite, we have a prerequisite electronic circuit and electronic circuit theory. Right? All these prerequisites. Does anyone didn't take this course? Does anyone not take those course there? No, everyone did. Everyone took the course, right? And good. So the next time I'm gonna send you a YouTube link. You can see through the lecture, okay? And every time we have a lecture, you have to log into the Zoom here like this, and then the TA will check the attendance, okay? And then once the attendance is checked, then you can go on and watch YouTube video, okay?